उठा कर जरा अरे साहब
Welcome everybody for my pre-PhD submission seminar, and first of all I express my gratitude to my guide, Dr. Dharmendra Yadav and GHRC, especially Director, GHRC, Dean, R&D, Coordinator and other faculty members, from where I get a lot of support for completing my work. And my title is Design and Implementation of Novel Approach for Information Security Risk Analysis in Smart Power Grid Systems. So it's a kind of interdisciplinary, transdisciplinary work. So their main focus is on the risk analysis. And like first let me give you some brief. Actually, this power system is a power. There was a concept that nobody knows about the people of power. They don't know about the IT, and they work in isolation. Now the time has changed. Their integration is required, and different type of technology and many things are required. And the main thing in power is that in every technology, in every area, lot of changes are done. But in power, there was no change since last 100 years. It's just that conventional method is there. And now this new concept has come that is evolved around 2003 is a smart power grid system. This is integration of ICT and different technologies. So when any new technology, new concept increases, so technically there will be a lot of challenges will be there. Then natural is there, the people who work in the power sector, they don't know about anything. So social engineering and other type of problems and managerial and operational challenges are also there. So my presentation outline is problem study, rational, objective, challenges, methodology, results, conclusion and references. Why risk analysis? Risk analysis is to analyze the risk in the form of the likelihood, how the probability is there, what is the possibility is there that this can be done, and what the impact level, how it is going to impact the system. And it is very important to analyze and to provide any risk mitigation. It's the foundation of any risk management approach. So that's the risk is the likelihood into impact. It helps to mitigate the risk. And if we talk about the security, in security, what happens that it can be the basic philosophy of the security is it can be man security, it can be technical security, it can be the basic fundamental basic concept is there. The more information you have, the more collection, the technology you have, the more knowledge you have. It means more knowledge, and more knowledge means the more powerful, the more you can handle the things, and you know how to control the security. Intelligence is more important in case of the security. It can be any security. The way and the approach will be changed, but ultimately it depends on these things. Basic fundamental concept is there for any security. So we are focusing on the cyber security area, that is on the power grid. So what is power grid? Smart grid? Smart grid is a critical cyber. Some people also say it's a cyber physical infrastructure. This is cyber physical infrastructure means just because of the cyber system, it's going to impact the physical system. All the physical devices, controller devices. Earlier, some devices were known as the industrial control systems, where SCADA system is there, PLC is there, RT is there. So it's an integration of this thing, ICT plus control system and traditional power grid. That's the complete. It's a smart grid. So lot of even to define the smart grid, still a lot of homework is there. There is no standard benchmark is there. We can say okay, these 20 points are there. Then we can say this system is a smart grid. These are there because the people of the power, and as per electrical engineering, when we discuss with them, for them smart means when there is no change in the something should be in the power generation, something should be in their efficiency level, in the frequency level, so losses should be there. For them, that is the power, that is the smartness. And if you talk about the technology people, they think about the application part. How optimize and how best you can utilize the things, how you can use the technology and to reduce the power loss and power generation transmission, because now time has changed that when the basic fundamental is you suppose many microgrids are there, you can integrate it. If suppose I have a house and I have the generation of 2 megawatt, if suppose I am using it to 1 megawatt, when can I sell that power? So lot of concern on that basis is evolving. So lot of challenges that is there. Cyber critical so it is a backbone of any nation's health. There every government they have list down the critical infrastructure, and in critical infrastructure, if we talk about the cyber this power, this is the critical of all critical, because any critical infrastructure is get damaged if the power is damaged. So it's more superior, more critical than other critical infrastructure. And nowadays, just last week only that Russia attacked the US. This Ukraine that attack was there on the power and they shut down there. So now this different cyber war has started. So just because of that, lot of things are there. So this is the complete overview of the power that smart grid is involved in everywhere, from the generation, transmission, distribution, industrial, service and residency. And when we talk about the industry, this ICT sector, ICT is involved everywhere. And this demand response supply is there. Demand response means if suppose how much demand is there, how to manage it, how to optimize it, how to sell it. Distribution of renewable electricity generation is everywhere. If suppose at home is also there, at the generation unit it should be there, renewable energy. Advanced energy storage system, because when you talk about this renewable energy, then storage is also required. How to manage, because nowadays it's very challenging in the solar system is there, wind is there, but how to store it and how to use it, that's also challenging. And grid optimization, advanced metering, electric vehicle charging and energy management service. This is the problem study. I have taken some very few work has been done in this area, especially in the cyber security area. Very few people have done some special work, like 2-3 people. One NIST as a body, NIST is working in US, and as a other in Europe, ENSA they are working on this area. Otherwise, they are working very aggressively. And if we talk about the research, this is the L. Langer, they study some SGIS toolbox of the smart grid. It was developed in the Europe. This toolbox is main is the asset driven. Nowadays, most of the risk analysis approach they are based on the assets, because they have to manage the asset. If the asset is controlled, then they know, and then critical asset they find which asset is critical, which is not, where they have to use the proper optimization technique. In use case they have used the control voltage control and power optimization, focus on power loss impact analysis, and they use a pragmatic way to identify the security need. Some practical approaches they have considered. Security level identification, they have used the general security mechanism, that is the ISO 27005. It's a general ISO standard. It's not specific for the power or and NISTR. It's specifically for the standard for the smart grid. Tool is not domain specific. It's not a particular any domain. It's a general tool. Proper best practices and mapping with the security controls. Proper which best practice there, how to, because that is very important to map the control security. Here I am using this word somewhere, sometimes a security mechanism. Normally in ISO standard they are using this term as a security controls. And that's why I wrote both it. Security mechanism is a security control system is missing. Likelihood analysis is missing in this area. They have approached the general concept is there, how to control the risk. RSUR, they have this is perspective based risk analysis. Different perspectives are there. If suppose anything happens, then in this case, if suppose any disaster is there, then in that case, it's also some different broader area they have considered. Different risk methods they have analyzed, and they also use the smart meter. And smart meter is also important in this area, because most of the nowadays this smart meter is the only thing that is implemented in many places. So it's easy for them to do some analysis work on that, and it's based on the Octave. Octave is normally used in the general IT technology. It's a methodology. Octave, Chorus, many research methodology, risk analysis methodologies are there. This is one of them. Mostly people they are using this in Octave, but it's not a ICS based, or it's not the general. And NIST 830 is also a general risk management approach. It's not a power grid based. Indexing principle is missing. Ranking is not there. Okay, suppose we can say rank that this is first number risk is there, second is third. Broader guideline, case study, impact analysis, smart meter. Smart meter they use because smart meter is not a critical. Smart meter is mostly, if suppose anything happens with the smart meter, mostly it happens with the, your privacy, confidentiality. That's the issue because of this you can at least neighbor can understand what is going on if power is on or not. On the critical area, not IT related risk analysis there. The CW10, this attack tree based methodology for impact analysis has been developed. Where system scenario and leak level vulnerability is developed. SCADA security framework includes the 4 components. They are real-time monitoring, anomaly detection, impact analysis, and mitigation strategies. General mitigation strategies they use. Evaluation system to evaluate the vulnerability. Real-time vulnerability is required for precision and to get the critical messages. Real-time vulnerability is not there. General vulnerability they use. Impact of vulnerability and other smart grid critical components need to be analyzed. A. Govinda Raju. This is the one of the best paper till now I have observed, and I have seen that, and even I evaluated this paper in my case study. They have done very good work in this area. This is the professor at Iowa State University, and they are working very aggressively in this area, and they develop many things in this smart grid section, especially for the risk part. Exposure evaluation method they have developed. You suppose any lack is there, any exposure is there. The security model is introduced to present the various privileged states, evaluates the viable path and that attacker can exploit. Untrusted area they have exploited. So their approach is to first find the untrusted. That is in detail I am using this paper further. There I will give you the details. WRIA, they have effective control identification assessment, is hazard identification. NIST integrated. This is nothing important in this paper. CW he is also giving us this guidelines. He is expert in this IEEE section. He just gives us the guideline. What guidelines should be there? He has not developed anything, and anything is not. And as per him, his concept is there. Anything should be implemented at the development stage of the any product, like software development, because mostly firmware are there in the smart grid. So in the firmware, there should be some approach should be there for managing the security. Hybrid risk management, this is also developed by the Europe. That is also like the SGI toolbox. Nothing more is there in that methodology. Kushner game theory, statistical tools, surveillance tools, personal smartphone use mitigations. Primary focus is not on the smart grid, it's a primary focus on the cascading effects, safety and security legacy. This is the paper that I found is mostly on the smart grid. Just somehow it's related to the smart grid, but most of the papers, one is the Europe and second is the Govinda Raju paper. These are the two papers that focus on this area. Rationale of study, need of information security framework for smart grid that have fizzled in light of absence of appropriate risk analysis from the beginning. Because the risk is the thing that if suppose anything you product or anything you produce and you suppose the proper risk analysis approach is there, trust will not be developed. If trust is not developed, nobody is going to use it. This is the basic. Even nowadays, finance sector is the only sector which is considered as the most mature sector in the security point of view. And still people don't trust it. Still nowadays also even people from the IT, they are also scared to use this online technology just because of this hacking and many things. And this is the area where people from the electrical background, they even don't know anything about so much these things. That's why it's supposed to be at the development stage. Need of selection appropriate security mechanism as per the NIST 853. NIST 853 the standard, they have given the security controls mechanism, and they have very effectively they have divided this complete security control system into 133 controls. They have given that controls are divided into 3 parts. One is the technical, operational and management. They have classified the controls, and on that basis I am also using this NIST 853 controls in my work. It's a technical, operational management. Lack of effective decision making system. Proper decision making system, supporting system is not available with any risk analyst. Now practically when risk analyst goes there, they don't have any decision support system, and it's a new risk analyst goes there, he don't have experience. And risk analysis, I think there were a lot of knowledge is required. Need a domain-based learning from experience, because if domain-based experience is most important, that people, if suppose anybody is working in the finance sector, if somebody sends him to the to do the risk analysis in the power sector, he can't do, because the priorities change. In power, the impact, the level is that first availability is the more impact than integrity, than in that this confidentiality. In this finance sector, the confidentiality is the first, integrity then availability. So priorities change and many things are changed. So he don't have the experience, so it's very difficult for him to implement the things. Standard methods are there, but this risk analysis don't need the methods only. Many other experiences, other things are required in that area. As per the survey, power sector comes under the worst implemented security mechanism and controls. Different surveys has been done, and as per them, very few investment has been done in this area. Key objective: develop the decision support system. Focus on legacy risk system. Here my focus was on the legacy system because these systems are already there, and whatever the problem with the legacy system, it's going to affect our future smart grid. And in future smart grid, many things are yet to come, and this is also going to affect when we do the integration. To identify the most probable threat to an organization on the basis of past attacks. My focus was to collect the past attacks and data, and from there make the system more knowledgeable and learning based, and that is going to help in future. If suppose I have the experience, I know these are this type of attacks happen, this thing happens in past, so how to solve that problem in the future if suppose anything happens again. Learning from the past, basic thing is there. And this is a key important point in security. To structure unstructured data obtained from different sources with the help of ontology. Because if we talk about the past attack, then we don't have any structured data. Somebody somewhere in their website is there, somewhere in there some data is there, different forms and different ways the data are available. Then we need to structure as per our need, and then we can use that data. For that I use the ontology concept to structure the data. To emphasize on countermeasure choices using the case-based reasoning to develop improved metrics, and then I use the case-based reasoning. It's a domain specific learning system. It's very good for giving the solution for the future on the basis of the past experiences. On the past experience basis, it gives the solutions, and on the other way, it also improve the learning also. To shorten the evaluation time period, operates type and strength. This concept is used just to shorten the thing, because immediately suppose anybody risk analyst come, how to do it fast. Due to cyber-physical and transdisciplinary approach, the risk analysis is a challenge, especially when it is a combination of legacy system and the new components. That's why I am using the legacy system. Zero-day vulnerability is more challenging. In the past attack learning system, then we can control the zero-day vulnerability, because most of the risk analysis now, what they are doing on the basis of the vulnerability database. Vulnerability database is available, and the problem with the vulnerability database is that if suppose vulnerability is available, then attacker do more attacks on that, because he knows. If suppose somebody says that you have to change the password of the router when you implement it in your campus, then he knows that this is the policy, but 80% will not change. So definitely what he do, he will hit there and he will use the default password. That's why these issues will be there. Zero. Risk analysis, IT related area like finance, aviation, business sectors are mature, standardized, unlike the smart grid. Smart grid lacks in security metrics and RA methods. It also lacks a historical vulnerability, which is helpful for domain-specific analysis. Past is lagging in that area. Database is also useful for characterization of attack probabilities and risk. Past attack data is required to make it more information correction. Then on the basis of information, it's more knowledgeable, then we can give the more specific decision or more selective decision can be done. To build and operate secure communication system for a smart grid, challenges which come across global domain areas is the smart grid network area. Where is the challenge there? The challenge is the interruption of the power supply through the network. Security services, safety and security. Security policy and operation, standardization of minimum security policies is there. Risk analysis, complex combination of legacy system and novel technology is there. That's why it's risk analysis is more challenging. This is the risk analysis integrated knowledge-based risk analysis framework is planned. In that, what we did, this IS NIST SP 882, they have already given the risk management framework. risk analysis. And what I did is that I integrated this framework with the existing framework, because my concept is to develop a decision support system. For decision support system is already is there. Whatever the important key points is there, because it's a general guidance. So this area is the area where I work, and this is my contribution area, that how to design this area is complete. First we have to security categorization is required according to potential impact, duration, confidence, integrity and availability. Security categorization is required because how to categorize the security which to find the impact. Practically what happens that normally if any risk analyst go and do this risk analysis, where the organization normally gives their impact. If suppose anybody goes to the one organization, as per them their impact is different. He says no problem, मेरी अगर ये चीज down होती है होने तो, but for me this is the more critical. So basically it is defined by the organization based, but there are certain common things which are the general experience, on the basis of general experience. For that I have taken this input from the different industrial experts, like those companies which are working on the ICS security, like PwC and all. From there I am continuing in touch, and from them I have collected the data and what general approach they are using. That formula I used for the general impact analysis formula is there, just to give the idea, because main detailed analysis will be done by the analyst at the organization base, and it changes everywhere. The main role of the analyst is to on the basis of experience he finds the likelihood. Impact is more dependent on the organization, section and anything else. Second is the structuring of smart grid, attack data, vulnerability data and ontological framework developed. Then use of case-based reasoning determine the likelihood, impact and vulnerability of impact factors to find out. Then risk level identification, risk matrix is developed. On that matrix we can list out and we can index the, we can give the ranking of the asset, which asset is more critical, which is less. Or on that basis is risk mitigation will be done. Because this is more challenging. The general approach is everywhere available, but how to, which asset we have to consider and how to consider it, that's the main challenge. For here I am using, my concept is slightly different. I am using on the similarity basis, on the frequency basis. Probability, to find the probability, here I am using the concept of the probability. If suppose like doctor do normally like that, suppose anybody is coming with this disease and 50% chances that they will come with this thing, it can be solved on the basis of experience. Same concept I am using on the basis of the past experience and learning. Okay, something is happening in this way. There is a probability that is going to help it. And for risk mitigation, because my area is up to the risk analysis, then I have given some my input for the risk mitigation. I use that this Pareto principle is used in this risk mitigation, because if suppose we have noted down the risk list down the risk assets list, then up to what level we have to implement and up to where, which risk we have to do the residual risk, or which where I have to invest, because lot of cost is there, where many other parameters are there to mitigate the risk. So how to, which risk we have to leave it and where we have to invest. So for that I use the Pareto principle. It's a general principle. It is very successful there, where if suppose you use anything 20%, then 80% things will be sorted out. So on that principle, general approach I am giving that in this way it will help you. The proposed novel based risk analysis framework is integrated with the NIST technical risk management, enumerated the key points related to the considered smart grid design, the network and software parts. This is the point, this is the suggestion I have just given here, because I have not worked on it. This is on the basis of past experience and on the my literature survey, and I found that this is a suggestion is there, because any product is developed. At the time of development, this network and software parts should be taken care. Then risk analysis application framework, an ontological framework for smart grid data, implementation of risk analysis framework.
Speed up a little bit, yeah. Get
Okay.
to your actual thing, yeah.
This is the background, this is the main discussion on that. This is the one discussion on that.
You established the context quite well.
Okay. Okay, directly come to the question. These are same things there. Anything important, relative maturity or understanding stakeholders, responsible professionals, managing. As per the relation of the study and other materials, the proposed integrated framework is broadly divided into three parts. I have divided this my complete work into three parts. One is the risk analysis application framework. Second is the ontological framework for smart grid attack data. And third is the implementation of risk analysis framework. In this first part, what I did is that I have taken the one of the best paper, that is the Dharmendra Yadav. I have evaluated the paper and implemented that on the one case study in the Haryana. There are the 14 pilot projects are in India. That is implemented up to a certain level. And in Haryana pilot grid, same thing I have tried to implement it and did the manual, the algorithm they have developed during the Raju. I did the same thing with the manual calculations and designed the new thing in the Haryana pilot. Try to understand, because as I said, only two type of work are there. One is the Europe, they are running on the practical area. The same line is mine, but he built some different area. For him, he's finding the exposure area, and that's why I collected this paper, and they developed very good things. And on that basis, I tried to find out where the problem is there and where I have to focus in this my further to work. This is the risk and the application framework. This is the structure of the one feeder unit I have considered for the Haryana pilot grid. What they did, there is a sensor is there, for field terminal unit is there, VPN 3G network, and this is SCADA system is there, and control center, this is the network is there. Switching distribution, switching distribution working is there. RT is the general how it's working. Directly I am coming to this area. So as per that evaluation that Govinda Raju, that the point is that first we have to find out the information object in this network, how these things are working. Means how the information data is transferred from the support field terminal unit to sensor unit. So this is the different information objects. Circuit breaker is there. From circuit breaker, how the data goes from data center to RTU, RTU to FTU and sensor. So it means anything happens in between this. Path is there. Read status, how the data is read from the SCADA read from the sensor send the data to this. That's why I have considered only 6 major points of the information object. These are object where attack can be happen. And this is the DFD of security mechanism pilot project, feeder monitoring unit of this is the development. Here we have find the which area is the untrusted data flow. This is the untrusted data flow. This border line, this is the trusted area. Here chances are there. So when untrusted is there is the chances that anything happens. So in that way the algorithm is there. As per this algorithm, they find the more untrusted area, and from that chances that the attacker will attack from the untrusted area, that is the exposed area. And from there how it goes, it check and it does this. This is the graph developed on the basis of the algorithm, how it goes. Because if suppose you got the path, then it's assigned 1, and then these are the security mechanism already we have considered where we see minimum security mechanism already there at the entry point. If suppose anything doing anywhere, the authentication should be there, encryption, data transfer there, encryption there. This basic security mechanism we considered that this is already there in the system. On that basis, these are the 6 information objects. On that basis, this analysis has been done. And this exposure evaluation graph has been found. Here 5 exposure is found out. IO 5, 6, 7. This the path are this. These are the path where attack can be happen from the untrusted path. So it is presumed that once the attacker got the access, he will not explore the other alternatives. If suppose he got the access, then definitely he will use that access only. So we have considered only one part. This is the 5 exposure values there 5. And the information object IO 4, 5, 6 get the link of vulnerable component location. Here it is RTU. And by work, this is the RTU is considered as a chances that RTU will get access because of this untrusted area. He will get the access here. This VPN and RTU, this is the untrusted part is there because it is of the 3G. Otherwise, here what they are doing, they are developing the VPN. And through VPN they are using a lease line and dedicated line is there. So chances are there. So this 3G is the only section. In Haryana they are using the 3G concept for communication. 3G is the only untrusted path. On that basis RTU is there. And if suppose RTU is exposed, so these are the already vulnerabilities available of the RTU. These are the CVSs, they have already given the list of the vulnerabilities. These are vulnerabilities there, it means the chances that vulnerability get exposed. So most probably this vulnerability can get exposed with the help of this untrusted path. This is the most risky problem is there. So my conclusion, the exposure matrix good in evaluation framework to enhance the risk management framework with the next alternative. But what methodology to be used to select the security mechanism control to mitigate the risk? It's missing there. What concept you have to use to mitigate the risk? If suppose exposure is there, how to control it? If suppose ultimately either you have to change the system complete, and what the other any other practical scenario is there. Information security is not purely a technical problem. As per the many studies, and it has been found that maximum breaches and maximum attacks have happened just because of the operational and management issues, not because of the only technical. retrieve the things. We are retrieving it on the basis of global similarity and local similarity. The structure we have developed, we have divided into two parts. One is the global and local similarity. Then retrieval is there and it's a goal. This is framework. Two retrieval approaches are used in this framework. One approach is the asset-oriented, integrated knowledge-based risk analysis retrieval engine is focused on the risk evaluation, security control, advanced. Second is the full-featured activity. This is the full feature is that suppose if you have to retrieve the things location-wise, area-wise, threat type, and type. So this is helpful. If suppose you want immediate decision and immediate solution, for that this asset-oriented is there. Risk analysis similarity function. This global similarity function is used with the help of the weighted weighted function is used for the categorization of the because the asset type, asset subtype, and asset type, asset type, and asset subtype is there. So on that basis, we have given the different weight. The more specific the thing is there, then we have given the more weight. The classification done on the basis of the requirement. The more weight is the more specific, so that we will get the best result. Asset targeted type substation. Suppose first is the global similarity. First part was the asset retrieval. In asset retrieval, we are focusing on the asset type and asset subtype. So what we did in this, we have given the weight to the only two parts, and the other part we have marked it as a 0. So it will from the same database, it will not retrieve that part. Only it retrieves the two parts. One is the asset targeted list. Here we have this asset targeted subtype. We have given the 60%, and this for them we have given the weight 40. Because the logic of giving this 40-60 is that because if suppose we give the 50-50, we will not get the result. If suppose we give the 70-80 and 30, then what happens that if suppose the data is there, that the similarity when it gives the similarity result, that the value of the similarity will be very low. And if suppose low value of similarity is there, then it's very difficult to identify that it's very effective or not. If we tried with different combinations, then we found that this is the best where we are getting the best result from by using of this combination 60-40. The risk analysis framework similarity functions like this. This is what we did. Only we need two parts in this. Other we don't require. So what we have, we mark them 1 and we mark it here. Its weight is 1 and all are false. So it retrieve only two parts in that risk asset retrieval part. Other like category, location, we are not interested in that. This is the complete asset retrieval oriented similarity function. This is the defined weight average. How it's calculated, weighted average, the calculator is followed. There is the complete full asset retrieval. Complete features are required. In that for complete feature we have used whatever in that also we have put 0 and 1 somewhere because that is not required. Suppose we don't want case number. Case number is no use for us. Then we are marking it as a 1 and 0. This is the area. Suppose we want only asset target subtype and this. What we did, we divided it into 9, 11 and 8. This weightage was given that we have considered it as a total 100. We considered as a total value should be 100, and we divided it into the total number of attributes were there with the 11, and that for 11 we considered it a upper value. Then in between low, medium, high. On that basis, we have divided into 11, 9 and 8. Next is the local similarity. Local similarity is required when complete and the hierarchy is there. If suppose any attribute level mapping is required. If anything happen in the hardware, which part is required. That and that case this local similarity works and it will help. In this also we have a low, medium, high. On the basis of low, medium, high we have divided into 1.8, 1.4 where it is given. Class A is exactly same as class B. Class A is highly to class B. Class A is somewhat similar to class B. This is the local similarity output from the CBR. Suppose we have given the only one value, then hardware, if the hardware is there, then it will definitely take out the hardware part, retrieve the part. Screenshot local similarity material asset targeted type. If suppose you do the asset target type, then as I said, 8.1 and 0.4 we have given the value. On that basis, if suppose anything is their application and application value is 1, exactly it will come out. If suppose anything happen with the OS, but it's a application part. Attack is there on, but it's a part of the application. Then it's we have given the value 0.8. If suppose SCADA is there, attack is on the SCADA, and it's a application part, but it's not matching with this criteria. So it's a 0.4 is there. the local similarity structure is given for analysis. This is a similarity function, local similarity screenshot of query performer. Suppose here we are giving the query for the, suppose we want to know the asset about what happened with the Siemens S7 PLC, and asset subtype is the PLC. The PLC, the asset is the Siemens 7 and this is the PLC. If we want to retrieve this two parts with the asset given, then this is the output of the similarity function on the two values. These are the five, because in my CPR what they do, it will not give the result in the one screen. Four results it gives, the next result will be on the screen. So here it is giving the asset targeted type, asset subtargeted type, 7 PLC, this, and this is the similarity weightage is given 1. This is the more matching is there. This is 0.8, 0.82, 0.6. In that way, it is giving the ranking of the similarity values. And this is the how to use this knowledge model in the application. IKBRS, there are the two applications. One is the full feature retrieval, and second is the asset oriented retrieval control identification. And two identification, this is the one knowledge based full retrieval. If suppose a risk analyst want to do the full retrieval part, then asset based, asset parameter, asset targeted gives. These are the different cases. Attack cases are there. Similarity measure is calculated, and the same way we do the iteration. Same with the other application. Other application is the asset retrieval based. In asset retrieval based, the same way there, but here it gives the query for the asset type and asset subtype. Knowledge based applications with the result out of the complete application. If anything asset targeted type is retrieved, communication protocol is there, subtype is the network component is there, then nature of attack is deliberate outside of boundary protection. Suggested technical impact is score is 10, boundary protection is 6, and average technical impact is 6. Here we are using the communicative impact ratios. Suppose same type of attacks are many attacks, it calculates the average and on that basis gives the impact value. Knowledge is failure is instructive. The person who really thinks learns quite as much from his failure from his past success. That's why we are using this the past experience and attack system are there. And this is the other level of validation on the basis of this scenario based. In this scenario based, this is the complete cycle of the validation. First we have to identify the asset, knowledge, CBR knowledge framework we do. Then risk identification is supposed to be done, control identification. Then here we are using the Pareto principle, that is the only 20% critical assets supposed to be used. If suppose this is a scenario, suppose we consider the scenario in experienced risk analyst has joined or any organization, query assets are deployed across the smart grid infrastructure. Suppose he search for the Siemens S7 PLC. Search for the Siemens PLC of the PLC type, screenshot asset based. Then control attribute, it involves the identification control security mechanism. It depends on the similarity weighted average. More than 20% of the cases are considered. On the basis of similarity, suppose the retrieves are done more than 20%. We consider only the top 20% on the basis of the Pareto principle, just to focus on that area only to do the likelihood and to use that likelihood for the further risk analysis. Model evaluation cases. In the same way, this is the complete database. If suppose here Pareto principle is used, and then if suppose it reviews the 5 cases, out of 5 only we are using the Pareto principle, so this is the highest similarity value is there 1. So we are focusing on this area. So as per 80-20, if suppose the result is there, if suppose any risk analyst want to do something else, then we can also use here. But as per our Pareto principle, we focus only on this main 20%, top 20%. Risk level identification, case by retrieval 40, 100, different case setup we have. First we tried to do this on the 40 data set, then we did on the 100, then we did on the 150. Then we found out that as the data set is increasing, the result is coming more clear. It means that the more knowledge, more data you have, the more accurate result you will get, the more database you have. Result risk analysis can take decision plan, detailed risk analysis approach, smart grid infrastructure Siemens P7. The organization medium, high risk divided into malicious code protection feature must be implemented to reduce the risk involved. This is the solution that the organization should do. Some procedure followed for identified assets. Eventually find assets and their associated risk level and control. Asset lying medium, high, low level. critical. However, the best approach is still the Pareto rule, 80% effective security. Now this is our conclusion feature work. Previous methods have been used in IT domain only, that is limited to only case retrieval. This method is using the taxonomy and other reason retrieval cases has made in dynamic. The case base is also used for evaluation different parameters for full feature retrieval. Conceptual understanding all aspects related to risk evaluation methodology and issue need to be taken into consideration risk evaluation criteria. In old isolated power system, security through security is well suited, but in this case of the ICS, in this IT based system, now it's not suited because when the integration is there, then more problem is there. The pragmatic approach to understand the smart grid scenario case study of pilot project is done. The legacy risks are considered which help to make the system knowledgeable for a secure and reliable feature smart grid. Novel approach of conceptualizing the domain dependent ontology and structured to unstructured data is used. The ontology also enlightens the requirement of different criteria, sub-criteria and their relationships. This IKVRA integrated with this IKVRA is developed, here risk analysis tool is developed. This Pareto principle mitigation suggestion. Novel approach conceptualize the domain dependent ontology. Ontology also enlightens the requirement of different criteria, sub-criteria. Future work factory level security method may be proposed to enhance the security assets in the future because when the product is developing at that time also so many security systems are supposed to be implemented, field level testing is supposed to be there. This can be taken care of. Next technical facility control are used up to the, we have used only up to the subcategorization level. And in further more categorization can be done and to get the more accurate result. For that detailed mapping of security control can be to make model more automatic. And risk method for future use of smart grid on cloud because the future is coming on the cloud and the approach supposed to be considered. And one is the semantic web technology may be incorporated with the CVR. Like here what we did, we use only ontology till the structure level. We have not used the semantic. If suppose you use the semantic and then we use this with the CVR, then it will become more automated. So these are my publications. One is the conference and 4 is the international journal, 1 is an Inter Science and some essay in Ghrce papers. These are my achievements. I got the best PhD presentation award during the first PhD qualifier. And second is I was ISO certified lead auditor. Exam I cleared it and I can do the auditing. These are the results.
If you can hear me, then
Yes, sir.
So I sort of got lost, there's a lot of detail that you have given, huge amount of detail. So to cut it short, can you give me your main contributions, where you think you have contributed?
It's a decision support system.
That's right.
And for decision support system, what we did, we have collected the past data, attack data, and we have structured it using the ontology. And by using the ontology and that structured data, we have used for in the CVR.
So this structuring of unstructured data and using ontology is one of the contributing fields.
Yes.
Okay, go ahead. That's
And,
one. Then
and second is that we use this data structure in the case-based reasoning for further evaluation. Data, the 2 types of evaluation are there. One is the asset-based and one is the complete parameter. Because nobody is giving this complete parameter based because it's a decision. The main objective is if suppose any risk analyst goes to any organization, he is not experienced and he don't have any because mostly what happens that risk analysis is done on the 2 parts. One is the analysis and second is the impact. Impact is mostly given by the organization. And the role of risk analyst and his experience comes from the his likelihood because on the basis of his experiences he do the risk analysis, and for that we have created this database. If suppose any risk analysis is new and he don't know anything about it, he go to the organization. Suppose Siemens S7 PLC is there. So what he will do? He will select, find the PLC. In past many attacks were there on this PLC, so it is more critical. So more focus in detailed risk analysis, it will help him out. If suppose immediately he is supposed to give any solution that he can do. First part. Second is suppose in different parameters and you want to analyze, if suppose location wise you want to analyze, if suppose maximum attack were done in the US part. So it means social engineering will be different. If suppose anything happened in the India, Then many other parameters are there, especially in the case of the power, like I did power pilot, I studied this pilot project of Haryana. I found that they have implemented and they are doing this pilot project. Even nowadays, the people of their engineering department, even up to the JE level, they don't call it a transformer, they are still call it a tanking. Even on the documentation, they are using it as a tanking. And even the level is there, and when we are thinking of the smart grid and the things, that lot of things are there. So how to sort it out, and so in that basis it will help us to find the location-wise attacks. If suppose the more benefit is, the more data attack is there, more result it will give to make the correct, accurate decision analysis. Because now, till now, nobody has.
I'm still getting lost. So you have to put me back on track.
Yes.
So for example, is your system going to be operational in a smart grid,
Yes, sir.
which will automatically say it's at risk?
Yes.
Is it expected like that?
No.
The system is running and somebody says yes,
It
there is a
will,
risk.
it will help the risk
Is it an
analyst.
offline processing or online?
Offline processing, risk
Not
analyst,
offline.
it will help the risk analyst. Because there is standard rules and regulations are there already. Government
They were never looking at the current state of the system.
Yeah.
They are looking at the general system.
General system
The
of
state is not an input to you. What is currently happening? Therefore, is there a risk?
now
For
nobody.
example, if I say my laptop is at risk,
Yes, sir.
then the laptop is switched off. That's a very offline kind of data. It
Yes,
may be
sir.
useful. I'm just
Yes,
trying to figure out where you are contributing.
Yes, sir.
So there is a power grid which is running,
Right.
and somebody is evaluating its risk,
Yes.
or just by looking at the constituents of the power grid, you are saying something.
Something, yes, sir.
So is it offline, online?
Data is on offline because it's a learning based process. Suppose if I learned something, I have a database. If I go to the next organization and there I found something new, then I will add it on my database. It will help me.
This is the learning of the individual. Individual is the system.
System. I am talking about the system.
Okay.
Because the problem with the individual data, suppose I go there and after 5 years I forget what happened in that area. So nowadays no system is there that will help the risk analyst to analyze in this way. Even in the industry.
So what is specific to the grid?
It's a
This
decision
could be for anything, right? Any
no,
system.
No, because it's a domain specific.
Where is the domain coming in? I want
Domain
to
coming is that because that priority we have defined. Because that
Can you show the slide.
the ontology. First thing is the ontology structure. First we have this structure we have
The
designed.
ontology structure turns out to be some questions, basically.
Yeah, that the questions and that everything were designed and structured were done on the basis of the industrial power sector.
So you have to justify why these questions are absolutely adequate and minimal to get it.
Yes,
Otherwise,
yes.
Anybody can ask any question.
Because these are the questions that normally we discuss with the expert from the industrial control experts. Because already some industrial control system is already existing and some people are working there but no research methodology is there. We discuss with them.
So let me understand. So suppose somebody writes answer to which controls were compromised in the attack event.
Yes.
Somebody writes some garbage in English over there.
Yeah.
What will you do now? How will you make it structured?
These questions, this is not a questionnaire for the people.
Yeah. Is it a menu-driven thing?
This questionnaire we have generated for
That's what, is it menu-driven?
Yeah.
Is it menu-driven that I have to only pick one and nothing else? Or I can write anything in English?
No. This question set are used for my creation.
Well, that's okay, but somebody will give an answer, right?
Yeah.
What will you do with that answer?
We ask the different experts and on the basis of that which protection is there he knows because the questions are asking from the experts.
That's right.
Then he says that which controls are compromised in the attack event. It means we have to focus on the control. Control means which security mechanism has been compromised. Suppose password was not there. Suppose
something almost arbitrary answers can come. How will you make it structured? It's not clear.
No. Just this is the only question just to get the idea. And on that structure.
What are you building your ontology?
This I shown is the validation part. This is the initial part I am showing. This. On that basis,
these questions are put, answers are taken.
No, answer were not taken. On that questions, we have structured this thing. General structuring was done.
So can you sort of justify, because this is a thesis, PhD work,
yes, sir.
You have to justify that this is adequate for most smart grid attacks.
Yeah.
How will you justify? You
like control asset targeted threat event. This is the next part. Control. In control we have used this industrial control system already used by the ICS cert. They also what they did the control this boundary protection were missing in the they found in the most of the 85 discoveries they have found. that where boundary
This
protection.
data is deciding your choice.
Yes, yes.
This is the factual data.
Factual data, yeah.
Okay.
Second question was asset targeted. Then on the basis of study and NIST and different standards, we have divided it into the 4 parts. This structure designing was done by us. This is my contribution. This is not others, because on the basis of the NIST standards are there. They have given the clear guidelines, but on that guideline we have to be specific and we have to zero down up to particular level. Then we divided it into the 4 parts. One is the hardware, network, software, and engineering. And that can be the more general things, but the attributes, when it comes to the attribute part, this SCADA, HMI, all these are the part of the smart grid or with the industrial control part.
But the workstation can have a lot of complexity.
Workstation has.
Workstation hardware itself is a huge piece.
Yeah, that's why.
And Intel can could have quietly put in a chip over there. There's a lot of also.
That's why I did 2 parts. One is the global similarity, second is the local similarity.
Okay.
In global similarity, it is the okay in the workstation. In local similarity, how workstation is with the web server was affected.
These are very complex things. OS attacks are
This
so
workstation is anything happens and it exploits the web server. So interrelated, this attribute is related with this. This was done. This I did in the similarity. I divided into 2 retrieval part. One is the global and this is the local similarity. This helps in the local similarity. If anything happens in the workstation, then it's a part of the web server or something else.
How can you guarantee that? It may not be part of the web server.
No, that's the structure I have derived. The weight has given. That complete modeling is done. On that modeling, that result
by you or by somebody else?
By me.
So that's what
that's the result. That's the result are coming. That's why the final outputs are coming from this.
For example, workstations are so complex. I'm not sure whether what you are modeling is completely adequate. If you convince me, I'm fine.
Yeah.
So, for example, OS. Take OS.
Yes, sir.
So, what is the role of OS in this whole picture?
Yes,
or
sir.
an application software and so on.
Anything happens in the OS part, that can be further classification can be done.
Because how it interacts with other modules in your picture.
If
There is something wrong with the OS. There is a malicious OS.
Malicious OS.
Now what?
And in industrial control, what happens that is OS is definitely going to attack, in fact, any physical part. That's why it's a cyber physical part.
It may not attack today. It may attack 1 year from now. They're very smart fellows.
That can also be there, because what I am doing is I am not projecting the future. I am learning from the past experiences and making it the knowledgeable, so that once it is knowledgeable, then it will help to decide on the future. Further categorization can also be done after
I don't know. I actually want to hide much of these blocks. I want lesser.
Okay.
I think it is too complex. I would love to have a simpler picture. I'll knock off the OS not relevant or whatever.
Because
and concentrate on the other grid-related hardware.
I categorize up to 2 levels. Even if suppose we study more, then 3 or 4 levels of the categorization is also required there. And I zero down on the at the level, and we are getting the sufficient result from this. Last time.
So come back. So what is your contribution ontology? I have understood now your questions and that part.
Yes, sir. On that question basis, on the basis of that question, we have structured these things.
One is hierarchy you have worked out based on that. Okay.
Asset targeted. If anything happens with the asset, that asset can be of hardware.
So show me that factual data again, where you have these frequencies, 85 something, which is the basis for your ontology.
Basic results, just this is a simple of the.
No, you had a table in which you showed the frequency.
First, these are the
same thing, but it was a number table.
Yeah, number table. This is here. This up to the this is statistical analysis we did without using the case-based reasoning. Up to that we are getting this result. And further, we can also get the these are the 2 parts through which we get the global and local similarity.
Not this, I'll tell you which slide. This is your slide immediately after the categorization of smart grid attack. Go back. Even further.
These are the retrieval.
Even further. Go back. Go back. You are way ahead. So you had those questions, right? 2 slides after the questions.
After the questions.
2 slides after your question.
Yeah, these are the results.
Go back. I'm looking for a particular slide.
Okay, got it. I got it. These are the questions. After
the question, a little more, one more slide. So top 20 categories of weaknesses identified by CRT. Where is that slide? Top 20.
CIE or
Top 20 categories of weakness identified by ICS CRT. You had it there.
yeah. This is.
Go ahead.
This one.
So why only top 20? And what role does it have?
Many are there.
So once you are going to 10, 11 and 85, anyway there are a lot of deviation.
Deviation are there. This is the data. This data was not created by me.
No, this data is somebody else's.
Somebody
You
else.
are gone right up to 10. Why not, for example, stop at 22? I'm just asking.
Because we are here. What they did is this up to this. It's cover the 69-70% of the attack was just because of this 20.
Okay.
70% of attack was just because of the 20. Other are very minor. And as I said that my focus was on the Pareto principle. The Pareto says that if you control the 20% thing, then 80% things are controlled.
That he told me. Okay.
Yeah.
That's fine.
On that basis, we are focusing on the top. Because when we go for the suppose we can get.
The other question I have is many of these attacks may be interrelated. They are not orthogonal.
Yeah, it may be possible that for one attack you have to implement 3 security controls. 3 security mechanisms are required to be implemented for single attack.
So where is that happening in your work? Is that
This Stuxnet is there. In Stuxnet, 3 vulnerabilities were exploited. In the case of the Stuxnet, that first what happened is the Stuxnet was what asset exploited. It affected the hardware and also affected the software. And Siemens S7, PLC, Microsoft Windows, these are the different assets they were affected. With a single attack, it affected the many things. So basically the malicious code was there, but on the other way, once security boundary protection is also supposed to be there, that is the main category. In subcategory is the malicious code attack. Because if the boundary protection is there, because why it happened? He is the person who used the pen drive there. And because of that pen drive, it entered into the computer and from there it is exploited again. So the 2 controls are there. And further, because as I said, my focus is up to the risk analysis part. Risk mitigation, I will just give the idea. And that's why then further how to solve it, on that I am not given it, because there is many other parameters come like cost, how to, which cost,
finance.
finance.
Better field now, fine. So what was lacking here? Maybe is there in your work. I'm only looking at your slides. I didn't see anything else. You should have a nice example, giving out everything that happens. So there are a lot of details, but if you have one running example of the system, the situation and what happened, not like this, a simpler thing. But this is an actual scenario. So it's very detailed.
This is the scenario up to the ontology level. That I validated ontology with this, up to this. In the second part, I give the second example. See, this is also the interpretation of my result, because this has also helped me to do the risk analysis. Then further result is, this is the second part, risk analysis. Here is the implementation. Here we are using one scenario. This is the application part. It's my work is on the 2. This is the model developer. There are 2 applications. Further we go to the after application. These are the 2 ways. And this knowledge build application. This is the results. Now here this is the case study. And this is the complete scenario. Is there from asset identification to critical assets. This is the scenario is given. If suppose anything happens with any case, I have taken one case, and how this case works, it will start from the asset identification. First it identify the asset, then it use it in the CBR knowledge, it find out what happened with this asset, what is the risk of that asset, and on the basis of this control identification there, then top 20% critical asset.
So is there an example which shows how these stages
this is the case. This is the first evaluation part I have shown. Then I have given the scenario. The scenario is
that explanation is not important. Even an experienced risk analyst can create a problem.
Yes.
So it is not very important that inexperienced one comes, isn't it?
Yeah, it's there, but
it's not an important assumption.
Yeah,
you can do that.
Yeah, because I have given such because my basic point is suppose any inexperience is there, for them more focus is there. Experience also, because it is based on the knowledge, because you can't say that X number of knowledge can be solved up to this level. If anybody more knowledge, categorization is already there. This is the asset, he evaluated, suppose he want to know about the Siemens.
These are unreadable, so I can't really read what you are showing. I have to rely on.
Sir, this is the asset targeted.
To read, yeah.
Asset targeted. He want to know what, suppose any new comes and he want to know.
So you are retrieving from the database.
Database. Yeah, this is a screenshot.
Okay.
Of the my CVR. In my CVR, he put it the inquiry. Query is Siemens S7 PLC. He want to know what happened with the S7 PLC, and he also entered the PLC subtype also. Up to 2 level he entered. He want to know what happened with this 2.
Okay, so I have a question here.
Yeah.
Since this can be partially filled as you said.
Yes, sir.
Can I fill any partial thing and something will come?
Yes,
What
sir.
is your retrieval?
Yes, sir.
Even if I fill one, something will come.
Yes, sir.
Right?
That's why I made two model. This is the application part I said.
So I have to
This is that's why I said. One is the full feature, and second is the only asset retrieval.
Correct. That's
The
right.
first example what I am showing you that is asset oriented retrieval. Second, the full feature. If suppose many things, if suppose I want to know the location, I want to know other things, that can be done with the full feature.
So how do you do? What is the internal algorithm
same-
I want to do? What is the algorithm?
This
There is
is
an existing database.
this is the structure. This is the weighting has been done for the full feature. We have given the weight 11, 9, 8. If asset target is there, we have given the 11 weight. If
So
suppose,
these are very empirical data. How do you justify them?
Sir.
And why these are static thing? Why don't they change with time? When new data come,
Yeah.
new things come, these weights should change also, no?
no, this is the retrieval. Suppose this retrieval is based on the this dynamic weight can be done.
These are fixed according to
Yeah,
what I understand.
it's a fix, and dynamic is mostly used in the location part mostly.
No, so
that
explain-
I am not focusing on
Explain the first row. I want to understand. What does it say?
asset targeted.
Uh,
We have given the asset
What is that?
targeted
Second
11.
column is
It's
discriminator is true.
Means that suppose we want to retrieve
Okay.
it.
Weight is 11.
Weight is 11.
And what is the last column?
Large is default function. What type of function? The default field is supposed to retrieve it.
What is the meaning of 11 now? Tell me.
11 is the weight we have given.
Means, which means physically?
Physically, it's higher weightage is there.
It means something, right? 11 means it was targeted 11 times or
No,
something.
weight is given retrieval because on the basis of the weight,
Uh-huh.
it retrieves the first it retrieves the asset type. With the similarity, this is CBR. The
So the
case
situation is you retrieve and give it to the person who is asking, right?
this is done by the software.
But it is displayed to the person who is seeking it,
Yes, sir.
right?
Yes, sir.
So suppose he does not like asset, he wants something else. Every time we will give him asset because it is high rank.
No, anything else can be there. Suppose this is a category. He suppose he put the category.
Then he will get category.
He will get the category. First, similarity, whatever the similarity retrieval will be there, it will be based on the category. If suppose he put all the things, then similarity will be based on the all weights. Higher weight will be the higher priority, and lower weight will be the lower priority. If suppose I don't have any use with the case name.
So why are many things with the same weight? Why can't we have 11, 12, 13 and not 3 11s? How do you
Basically,
justify
these are the
same weights?
different type. This asset type is a different area.
That's true.
This is the categorization, locations are different.
Yeah, that's true. There are 3 11s out there. I want to know. These numbers must have a meaning, right? Three weights with 11. Why are there three weights with the same?
These are the 3 categories. First is the I categorize the asset in 3 parts. Asset targeted subtype, and then asset targeted type.
Some keywords are there. Fine.
Okay. Then similarly category. We have given the category 9 weight because in category only one is there. Then there is the location. Location we have given the 8 weight, and month we have given the 8 weight. Month and
So are these arbitrary or they have a justification?
just a justification.
What is justification? Tell me.
This is the weight. This weighted percentage we have used.
So suppose somebody questions why
Yeah.
11 into 10?
Yeah,
Not something.
that's why I said suppose what I consider is 100. I said 100 is the best value. Suppose combine all the things, total sum should come the 100. And whatever the parameter we have the 11 parameter. We divide it into the 11, then we get the 11 value, and that 9 value and then 8. What we did 11 we put in the low, medium, high, because normally this is the low, medium, and high. On that basis we divided it into 3 parts.
So you have pre-assigned 3 values, 11, 9 and something.
Something
On
on
you
the
have
basis
given
of
them W1, W2, W3 also. And it
Yeah.
would have been deduced by the system what they should be.
Yeah,
Instead,
yeah,
you have
also,
given
yes,
first value.
it can be changed. It can be changed here. Now it can be changed with the this manual
It would
system.
be nice if you justify it from your practical data that these are good numbers.
The
That's all
result,
it means.
yes, yeah, result what we are getting from this the
Not
result.
from the result, from
Yeah.
something else. This is result by accident also can give you good values. But
Yes, sir.
when you assign some weights for a realistic practical scenario, there should be some justification
Justification like
from factual data.
from factual data there is
So you justify that
yes.
3 levels are important. That is fine.
I did many iterations in that. Practically,
You should give the result of a iteration somewhere, and say that this is why I got it.
I tried and then I found that this is the best result we are getting here because in level 9 and 10.
So then you should just plot and show with different value, this is the best.
I tried because then I found that it's good, then we use it.
Okay, fine, go ahead. So this is clear.
Yes.
Then what was it? So basically everywhere where you use empirical numbers and say this is what I have chosen, if you could sort of give some justification that this is not an arbitrary number, it has come out of experimentation.
Yes, sir.
Then that is justified.
I tried many combinations and I got the best result.
Sure, I'll just try to figure out. Okay, so the ontology part is clear to me. What is your second most significant contribution in the thesis?
This asset weight and this is the second part. Retrieval part.
That categorization.
Categorization and further.
And I just go ahead with that 40 scenarios. So how did you get these scenarios? 40 cases.
First what I did, I used only 40 databases.
So these are pre or you generated them?
No, it's it's a practical data.
Existing data.
Existing data.
Okay.
That data I have collected from the Ghrce database and National Vulnerability Database.
Okay.
Or all these are the compromised data. Which are already attacks have been done. And on that basis, first I use this 40 data. On 40 data, I try to just calculate these things. And then again,
So the database has 150 cases. You chose some 40. Is that
first I tried on the 40.
Some 40. You chose it.
I chosen only 40.
Okay.
Randomly I chosen, even for validation also. For validation also I chosen the randomly. Because in list I will show that coming out from sequence from any number is coming out.
Right.
Then 2 to 100. This then what I found is that 100. The point concept is that secure this scenario 3 is almost accurate. As case base increases, the accuracy is also increased.
And how many total cases are there?
I used only 150.
Those databases 150.
150 total. And for validation, what I did, I divided it into 70-30%. And 30% is 40 data were there. And out of 40, 30 data was like that's a complete different data. There's some data with the match, so I haven't used that data.
Yeah.
And I use only that data.
Okay, so now interpret this table for me. So this is one of your results, right?
Yeah, this is the just analysis. Result
This is not analysis.
No. This is the analysis and this is the risk. One thing I think one is missing here. Risk matrix table है यहाँ से. Oh. आपको लिस्ट में होगा सर
There is a risk matrix.
matrix is there. That risk matrix help to get this result. That is missing here. Yeah. From that risk matrix we are getting this risk level.
So this is classified, is it?
Yeah, this is classified from that risk matrix. That is missing.
Yeah, you had that.
Yes, sir. Yeah, that,
that
from there,
right.
that we can find that it's a critical risk is there where it resides on the basis of these values.
Yeah.
It's missing here, right?
No, I think it is there.
Yes, sir. Yes, sir. On the basis of that risk matrix, this is the result we are getting.
And according to you, these results are relating to the reality.
Reality.
Right?
Yeah.
So how many levels of risks are there in overall
3.
system?
It depends on the
Medium
classification, how
risk,
you can
medium,
do
high
medium,
risk.
high, medium, low.
Low also must be there, right?
Low must be there. Because then only we can decide, because main problem with the security is that where we have to focus. Because cost is also there. That I have not considered it, because my focus was only to make the system, it's a decision support system to help anything. It's not a complete detailed risk analysis. In detailed risk analysis, what they do some financial section is also there. That's why I am using it's a technical impact. I am not using this financial part is not there. Till now, nobody has used this CBR for this, especially in the power grid, even in other sections also. The multiple iteration has not been done by anybody. especially in the cyber case.
So as of today, I don't know the data. How many known attacks on the grids are there? What is the latest literature on this?
Sir, this is the latest data. As per the latest literature, I have considered maximum data.
Whatever you got, you already.
Yeah, I got everything. Because not more than it is available. Because not what the industry, what they did, they started commercialization. It was available freely. Now ICSR is giving the data. They are giving the vulnerability. Every week I email is there. That every week they give the list of the vulnerability of the data. But problem with that vulnerability is that they give that vulnerability. The main problem with the vulnerability is that you can't find the 0-day vulnerability, and it's not so much helpful. Because my focus is to make the system learnable, that we can help for the because maximum attack was due to the 0-day vulnerability is the more challenging nowadays. If any vulnerability is known, then that's in other way. It's also discussing now. People are working on that line also. They are saying if vulnerability is known, it means it is more treacherous. If you are given the vulnerability, then more chances are there attack will be there. Because I know the vulnerability. I know the vulnerability is suppose I give the example of any that Siemens has PLC. Manufacturer किया कंपनी के अंदर गया इंडस्ट्री they have installed it as per their guidelines. They are supposed to change the password of the PLC. The standard password is there, they don't change. And vendor knows this is the problem with the Siemens device. These are the vulnerabilities there. Definitely he will try he will get access. So yes. I got this idea, sir. Actually, I like this because I have to give other data also for comparison, different locations.
So which is the latest publication? What is the list?
But inter-science journal.
They have accepted that, right?
Yes.
Inter-science.
Inter-science.
This there is not. Which one? No, your publication, not the publication. Yours. Which is the latest in this?
These two are the latest.
Ontology you have already described.
Yes, sir.
So that's okay. That's one part of it.
Yeah. This that I have
Risk analysis.
risk analysis. Here I have I given the suggestion that the part that industry is supposed to control the software and the network part at a part of the design. This I found out from this is the outcome of this paper. Because the maximum we can try to reduce it at the development part only. Now what maximum general practice there we start to do the risk analysis after when the system is developed. We don't start from the cycle. The maximum in industry because all these component this industrial control devices are there. They are the firmware based, and so in maximum problem with their software. Not pointer error is there, some analysis is there, anything malfunction is there. That's the issue with this hardware part. The maximum vulnerabilities are there.
So why do people attack grids? What for? Other than stealing power, I don't see any reason why they should do it.
Now it's a part of the cyber war. Just last week that Russia attacked US.
So that is denial of service.
Yes, denial of service because see there are the main attack will be on the critical part, critical assets, critical infrastructure, and power grid is the only critical infrastructure. That is if suppose you attack it, you can directly attack all other critical infrastructure.
They have redundant system, right? So if something failed, they should have another backup somewhere.
It's not there. That's the problem.
It's not there?
No, it's not there. There's the maximum issues there. In power, if, like in the previous cases, even in defense, general लड़ाई का भी जो concept है, that is on the same way. Now we are doing on the cyber war.
Yeah, that is.
पानी supply बंद कर दो, सब कुछ बंद हो जाएगा. The same way, control, close the power, then everything is controlled.
And if you stop the network,
everything is controlled. And the power grid, this smart grid, even people are objecting for this. Like here, people are objecting for the digital transaction because they says everybody knows about financial status. The same problem with this also. Now in US, they have objected using this smart meters. But they are saying if suppose you use the smart meter, this AMI is the smart meter, you can get the complete detail how many devices are used in your house, AC is used or not, this device is used or not. If suppose they are saying, suppose we are out from the house, it means our device is off. You can check it from the meter. Okay, nobody is there. Go and do something. So in other way, it's very challenging. Very many problems are there. And second challenge is with the generation part, because what smart grid says, suppose my house is 2 megawatt generation, I can give 1 megawatt. And if suppose any rain happens, anything happens, and I have committed for the 1 megawatt, how it will happen? How to solve it?
That is a constructive. That is good.
Yeah.
What you are looking at is the other side of
Yes,
it.
sir. I am focusing on the cyber part.
Okay, fine.